Okay, this is my second attempt at making silver hexachloroosmate from scratch. Once again, I am starting with a solution of bleach that I've added a somewhat considerable amount of sodium hydroxide to, so it is very, very, very caustic, which is good for preventing osmium tetroxide vaporization. Now, I don't think the camera can pick this up, but there's a very small amount of either sodium perosmate or sodium osmate on the bullion still, on the osmium bullion. So when I put it in, some of that might dissolve, but the metal will not. The metal will not dissolve in bleach at room temperature. It needs to be heated to higher temperatures. It's a very inert metal. It will not dissolve in hot aqua regia. It will not dissolve in hot acid peroxide. It will not dissolve in hot concentrated sulfuric acid. And even concentrated nitric acid won't react with it at room temperature. In there now. As you can see, like I said, it is not dissolving at room temperature. The metal requires very high oxidation potentials before it will actually react. That's why we're going to put it in boiling bleach. Alright, we're getting up to temperature. The metal is dissolving. We're producing a solution of sodium perosmate. I'm going to need to dissolve quite a bit more this time if I'm going to successfully make the silver hexachloroosmate salt. Okay. Alright. Put the key back on. Dissolve a bit more. Alright. Probably a little bit more. Just to be sure. Alright, there we go. That's good. That's probably good. Okay, so now we have a very dark red solution of sodium perosmate. Now I need to add hydrogen peroxide to this to neutralize any remaining bleach so I can start reducing it. Okay, you'll see here, this is a very, very dark red. Alright, just transfer it over. Getting as few solid contaminants as possible. Okay. Okay, now I'm just going to add some hydrogen peroxide to the solution to neutralize the bleach. Oops. Okay, now I'm going to put the cap on and swirl that around because it's getting a little, there we go. Still a nice deep red color, that's what I like to see. That means we got a lot of osmium in there. Alright, hopefully we've neutralized a lot of that. Alright, we're getting turning to red-orange now. And I'm going to start adding isopropyl alcohol to this to reduce it from sodium perosmate to sodium osmate. And look, it's going already. It's already reducing. Look at that. Add some more, I think. Add a bit more. Yep, there we go. Look at that color change. It's pretty damn amazing. Rather quickly, too. No heating required. Alright, this next part involves a lot of stirring and a lot of heat. Pushing that up a bit. There we go. Stirring back on. And let's crank up the heat. Let's get this to reduce even further. So what we're doing now is we're going to start heating up the isopropyl alcohol so that way it can reduce the sodium osmate to osmium dioxide. This will also boil off the isopropyl alcohol, and while we're at it, we can also boil off some water so we can get this solution more concentrated again. Still waiting. Oh, wait, no, it's starting to darken. It's starting to darken right now. Alright, that's cool. That's good. That's very good. Alright, don't want that bubbling too much, but yes, we do want to start reducing the osmium in there. And I also definitely want to boil down that solution a bit as well. I'm going to let this run for a bit. Okay, so I've been boiling this down for a while. So now I'm going to take it off. I'm going to start adding isopropyl alcohol to it. Okay, here we go. And add a little more just for good measure. There we go. Put the cap on, swirl it around a bunch, get it nice and mixed up. Get it really mixed up. And okay, back to the heat. Alright, and we are back on the heat now. Just loosen this cap up a bit more, there we go. Alright, so what I'm doing now is I'm just adding even more isopropyl alcohol to this. Alright, because you want to just keep on doing this until you get all of the osmium dioxide out of there, because you take a look at that. Actually, you can't see, but it's still purple in there. So that's how I know I haven't got all of it out yet, or even all that much of the total. But I know if I centrifuge this now, I get all of it separated, the solution is going to be still quite purple. And so here we are back on the heat again. I have to do this over and over and over and over and over again until all of the dioxide is out of solution. It's going to take a while and probably going to go through a lot of rubbing alcohol, but you know what? It's worth it because you won't get any colloids this way. So I've taken it off the heat again, and already you can see at the top, the osmium dioxide is beginning to settle at the bottom. And the isopropyl alcohol is to thank for that because it promotes coalescing. Absolutely. But I am guessing I still have a long way to go to get all the osmium dioxide out of there. Okay, now I'm just centrifuging it to get some of the osmium dioxide separated from the solution. And this is very, very coated with some of the dioxide. It's not much, though, but it's not nice to look at. I can't see how purple the solution is. So, yeah. Alright, so as you can see, the solution is still quite purple, even though I've isolated quite a bunch of the dioxide, but there's still quite a ways to go. Alright, so I put this on pause so I can go inside, have some dinner, and just relax. Now I'm getting back to it. This takes a long time, and it'll probably go into tomorrow as well. Yeah, this is very time-consuming, but the isopropanol method ensures you don't get colloids. You get all the osmium dioxide out of solution every single time, always. And I'm just not going to risk not being able to do so. So, isopropanol it is. Alright, so what I did this time was I centrifuged the osmium dioxide out of solution. Then I let the clear sodium osmate solution boil down a lot. I boiled it down to about right there. So that way I can start adding larger quantities of isopropanol to the solution. And hopefully I can start reducing more osmium at a time because I'm adding more alcohol. And now I'm boiling it again and reducing more sodium osmate. Now you can see a lot of the alcohol boils off pretty quickly. And then you have more time for the alcohol to react at those temperatures while it's boiling off. And the idea is that hopefully each repetition I can start extracting more dioxide per repetition. So that way, hopefully, it doesn't take as long. Okay, I just added more isopropanol. And as you can see, it does cause the particles to coalesce. As you can see right there, they're coalescing at the interface between the alcohol and the sodium osmate. Okay, so here are the next steps. I'm going to be taking this osmium dioxide here, and I'm going to be pipetting it into a centrifuge tube, this one right here. And I'm going to centrifuge it so that way all the osmium dioxide gets plastered nice and flat at the bottom of the tube. Then I will take the desired amount of hydrochloric acid, pour it into the tube, so that way I'm not diluting the hydrochloric acid. So that way, when I dissolve it, I can achieve the desired concentration of chloroosmic acid before I go ahead and precipitate the ammonium salt. Okay, I did not film the part where I went ahead and I stirred up all the dioxide, but I'm going to go ahead and film this part just because. Alright, let's get the rest of it. I keep cycling it like this, that way I can get all of it as much as possible. Try and wash as much of it down there as possible. Try and cycle it out of the pipette. Because some of it will inexorably get caught up in the pipette. All right. I'm just going to add some more water to this and then we'll be... Okay, so I centrifuged it a second time and I'm unable to remove any more water than this. So unfortunately, I will be diluting this down a little bit. Hopefully not too much. All right, here we go. In it goes. And I'm going to cycle it in and out. There we go. All right, so now we start boiling. Okay, put the cap on lightly. All right. Start stirring. And turn on the heat for sure. All right, let's make our chloroosmic acid. All right, still waiting for it to get hotter. Some of it may have dissolved already, but still waiting for it to heat up more to start dissolving more osmium dioxide. The platinum analog is much easier to get. All you do is just dissolve platinum metal in aqua regia, but you can't do that with osmium, so you have to take the long way around. Okay. Maybe just take that off the heat. All right, and here is our solution of chloroosmic acid. It's a nice amber orange color with faint hints of yellow and green. It's a very nice color, actually. Okay, now we need to add some ammonium chloride to precipitate the ammonium salt. Now, if it doesn't precipitate enough of the salt, then I'm simply going to evaporate it again and then wash it properly this time. Not using ethanol, definitely not. All right, so I'm going to be adding a fair amount of ammonium chloride this time. I'm going to go ahead and add it in. And start precipitating. And already we're precipitating it. All right, time to get on the stir. All right, start stirring. Yeah, let's turn very red now. Very, very red. Very red. All right, we just want to dissolve all that ammonium chloride, convert all the osmium to the ammonium salt. And then I'm going to centrifuge it to see how much of it I can actually isolate. Okay, so I can see a lot of the ammonium salt settling out of solution. Yeah, it settled right out on the bottom there. Mix that all up. Swirl it around a bit. And let's just see what happens. That is quite a heavy precipitate. You can already see it settling at the bottom. And yeah, I'll just centrifuge this and see how much of it I can actually isolate. That is quite a lot of our very, very red salt. Yeah, look at that. There's quite a bit of it in there. It's all settling at the bottom too. Look at that. That's pretty crazy. You can see it right there. It's very red. All right. Oh, yes, there we have it. That's our ammonium hexachloroosmate. All right. Now let's get the rest of this solution back into the vial. Okay, and I'm back. The centrifuge tube is inside the desiccator bucket, and I got the evaporating dish. Okay, so I'm going to take the cap off of this, and I'm going to transfer it to the evaporating dish. All right, here we go. Once again, we got a nice lemon yellow solution. Looks a little darker on the camera, but in real life it actually looks a sort of greenish. Yeah, that is a greenish yellow, actually. Yeah, absolutely. That is definitely a greenish yellow. Okay, in you get. Alrighty, that's going into the desiccator bucket. Okay, so this looked pretty dry, and I tried removing some of it. I did get a tiny bit out and into a bottle, but it is still wet, and it was even wetting the wax paper that I was using. So I need to let this dry some more. And I don't know what it is about the centrifuge, but whenever I just leave things in here for days on end, they dry out pretty well. And this time I'm absolutely fucking determined to get the rest of that out of there and into that bottle, just as a consolation prize for myself. So I have added a bunch of sodium hydroxide into this vial next to it, because like I said, fucking determined to get the rest of it out of there and not losing a bunch of it just because it's wet. Okay. The rest of this looks like it has dried. Okay, so now I feel even more determined to get the rest of it out of there, because now I have replaced this tube and this tube with sodium hydroxide. So now I have 3 tubes full of sodium hydroxide just to finish drying out this one. I am gonna get that stuff out of there if it kills me. Okay, here it is. This is my consolation prize. That is nearly pure ammonium hexachloroosmate. And it is indeed a very dark red. You can compare its color to the cesium salt, which is very orange. So we have cesium hexachloroosmate and ammonium hexachloroosmate. Both samples that I'm going to keep. Okay, so now that I've isolated my nice sample of ammonium hexachloroosmate and got a nice, beautiful new picture of it on the Wikipedia page, I no longer care what happens from here. If everything goes tits up, that's okay with me because I got my sample. It's my consolation prize. Now, I've got the remainder of the ammonium salt in here. You can see that. Got the camera oddly placed, so I can't really tell what's in frame and what's not. So, just as a proof of concept, I'm going to add some deionized water into this, which I have here. And then I'm going to add a little bit of the silver nitrate salt, just to see what happens. Okay, we should get a sort of very light green, slightly yellow colored solution. And when we add the silver nitrate, it will produce the insoluble silver hexachloroosmate salt, which is, I've read, deep brown in color. So even if we can't see any precipitate, the color of the solution should change because we may get a colloid. But hopefully that colloidal color will be brown. So, yeah, let's get to it. we have a greenish colored solution. If you can see that, there you go. It's a greenish yellow colored solution. And stick it into this vial. All right, if you can see that, there's our slightly green, yellowish colored solution of ammonium hexachloroosmate. All right, and now I'm going to add the silver nitrate to it. Tiny little bit of it. See what happens. All right, here goes nothing. All right, it's in there. And look at that. That is, wow. Oh my God, there's a lot of it. Holy cow. Oh, can you see that? That is silver hexachloroosmate, if you can believe it. If you can even believe it. There it is. We made a lot of it. That's a lot more than I ever expected. Holy cow. There it is, folks. That is silver hexachloroosmate. Right before your very eyes. That is an excellent proof of concept. It looks brown. But I shit you not. It's actually green. It is actually green. It's such a dark, dark green. That is incredible. I'm blown away by that. Okay, so I was going to wash this ammonium hexachloroosmate evaporite with a 1-to-1 ratio of saturated ammonium chloride and deionized water with a splash of hydrochloric acid. However, it would appear that it has already mostly decomposed. There is a small amount of the red salt left, but the rest of it looks to have decomposed to a sort of blackish substance, which I can assume might be the dioxide, or it is some other form. I don't know. But even the crystals have changed color. They've turned dark. Yeah. So I guess I won't be doing anything more. Well, that's disappointing. Okay, so while it is disappointing that the rest of my ammonium hexachloroosmate decomposed all on its own, what I have here has not decomposed yet. It's still perfectly intact. It's showing no sign of decomposition whatsoever. It's still very red. And I enjoy it. Over here we have the cesium hexachloroosmate, ammonium, and the silver hexachloroosmate right here. And as you can see, it still has that pale green color. So yeah, 3 different hexachloroosmates. Thank you for watching. I hope you enjoyed.